Welcome to Technocraft Academy. My name is Timson. Remember from the last class when we started out with functions, and at the very end of the lecture, I said we're gonna be our next lecture will be starting from local and global variable. Then we move towards redox function, lambda function, more advanced functions like that. So today, without forgetting what we've said ab initio, we're gonna be starting out with what we said or what we promised. So let's go to our command prompt. If you're on Windows, right now I'm on Windows, so command prompt. If you're on Mac, you go to terminal. You don't need to run as administrator. If you're on Windows, you can just open directly. So you cd to desktop, desktop, and if your command of cd into desktop is not working, try cd into download or cd into document. And of course, if you are on if you're using a mobile device, just create your folder the way, or your directory the way you've been doing. So I don't need to go into details as to that. So that said, so let's make directory, make dir. Of course, remember, directory means making directory simply means creating a folder. Like I always told you, directory means folder. So make directory, let me say func continues, continuation of functions, func continues. You can name it anything you deem fit, but I'm naming my own folder this way. So func continues, let me cd into it, func continues. So I'm cding into it, for continues. Okay, sorry, excuse me, I'm missing. Oh, okay, I misspelled continues. Okay, let's just leave it like that. Okay, I'm cding into it. So let's navigate to our VS Code by typing code space dot, punch enter. It will route you to VS Code. Yes, it has. So okay, so it took us to VS Code with a very large page. So we're gonna be I'll be trying to zoom in a bit so as for me to do some settings before we proceed. So let me close this. Let me zoom in a bit. Okay, so let me create a file, a new file. Let me say okay, let me say scope, variable scope. So .py. You can name anything, you can name your file anything you want, but I'm naming mine variable/scope. So open it. Let me create a word wrap. So as for each of my texts or my content, the content of my code to come in a new line if I've exhausted space on my system screen size, so that I won't lose some content in as a result of me overusing my screen size. So that is that. So let me create another file. Say text file. So let me just create text.txt, or let me call it notes.txt, so as for me to give some notes as lecturing. So that is that. Let me zoom out so that you can have a clearer vision of what I'm saying. Let me go ahead and collapse this tray. Yes, perfect. So that is that. So what is local and global variable? We have variable scopes. Under variable scopes, we are going to be talking about local variable, and of course we're going to be talking about we're going to be starting with global. Let me start with global. Global variable, and what local variable. Local variable. What is global variable? What is local variable? Local variables have scope within the body of the function in which they are defined. That is local variable are accessible inside a function. So that's just a simple meaning. When you create a function and you're trying to access some command within the body of the function, that is local variable, while global variable are accessed inside and both inside and outside of the function. You understand? So if you try to if you try to access a local variable outside of the function, you get an error. So global variables are not bound to any particular functions, and they can be accessed within the body of the function, outside the body of the function, or by any other function. So that is that about local variable. So the changes made to local variable to global variable by any function will be visible by other functions. So if a function needs global variable, the first statement of the function must be this. You must create a kind of global, then you state the identifier. Let me say, I don't know the identifier, so let me say identifiers. Let me say identifiers. You understand? So you know what identifier is. Identifier is one or more identifiers separated by commas. Identifier listed in global statement are referred to as what? Global variable. So global variable, you can there is a keyword global. The word global, there is a keyword to define a global variable. Otherwise, on an unbounded, you have an error called unbounded local error. It's an exception that is raised because the variable is uninitialized or unbounded. You understand? This is the error you get if you don't use the keyword global. Unbounded, I think unbounded error. Yes, unbounded error. It's a kind of exception that is raised because the variable is uninitialized or unbounded. You understand? Local variable. So that is that. So let me create. Let's see how this is working in practical. Let's say we have let's define a function. Let's call it, say, compute, for example. So we are creating let's say compute. Let's say we have a global x. Let's say we have global x. So we can now say, for example, print. We can say print. We can say print. Excuse me. We can say print. Okay, let's say value. Sorry. Value of x. Value of x in compute function. Compute function is is say x. You understand? Is say x. Let's now increment x by. Let's increment x by 5 and return none. You understand? Return none and return none. You understand? Let's now create another function that displays the value. Let's say def, or we can say display display value. Let's say display value. Of course, it's not gonna take any argument. Let's say global x. Let's say print. Let me create space between them. Okay. Let's say print the value of the display function. Let's say the value of x, and then display value. This value is x. Is x. Then let me increment x. let me decrement x this time, sorry, excuse me. Let me decrement x by by 2. Let me decrement and return 1, return none. You understand? So we can say x equals 0 by initializing. You understand? So let me call the function. Let me invoke the function. So let me not pass any argument. Let me create this value. I'm not passing any argument. Not passing any argument. You understand? Okay, let me call it again. Compute. Okay, let's run it and see how this is working in practical, so that I can explain from there. Let's see if it will give us error. Okay, the value of, sorry, typo error. The value of x in compute function is 0. The value of x in the display value is 5, and the value of x in the compute function is what and the compute function is what, 3. Now let me tell you why this is like this. If you see, normally initializing normally by convention, it's always before the function, you understand, or inside the body of the function. But because most times inside the body of the function, pardon. So because we have used the keyword global x, so you can use it anywhere, it can be accessed anywhere, you understand, because it's on a global scope, you understand. Then here I said print the value of x in compute function, which is x incremented by what, x plus incremented by 5, then return none. Here the same thing, decremented by 5, I mean by -2. So because I call this here, it will give me this incremented value, and I call it here, it gave me the what, decremented value. So because x can be what, accessed anywhere. That is that about it. That's that about global function. And of course, let's move to what, local variable. You understand? So by local variable, I don't know if let me comment this and make use of this. Let me comment this. Okay, let me just comment this so that I can make use of this. Let me comment this. Let me go off with this. So let's say we have let's say, I don't know, this. Let's say we have x plus equals, say, 5. Yeah, for example, when I say print the value of x in a function, when I say print value of x in let's say value of x in a function is x, and I said say return. You understand? So I'm not calling a local variable against it. Let me now say x equals 10. You understand? Let me say compute x, compute what, x. Let me say compute and x. Sorry, I use uppercase here. Let me use lowercase. So that compute s. Oh, I don't need to use compute, sorry. Let's say this value, this value s. So I'm calling the function here, let me run it and see. Let's see what this gives us. Sorry. Oh, sorry. Let me give you the value. Okay. Let me give you the value so that's okay. Let me run it again. Yes, I think that was the error. Okay, so the value of x is what? The value of x in function is what? 15. So that is that. And the main program here initializes the value of the local variable x, at it initializes it at x equals 10. You understand? So the variable x is then passed to the this value, display value here. You understand? Display value function as an argument. So of course in the display value function, the value of the value of the parameter x is incremented by what? By 5 here, which we say, and of course making its value 15. You understand? So but x being local to the function, the modified value of x15 is visible only within the body of the this value function. You understand? So when you displays the value of x in the this value function, it will print the modified value 15. So that is that about it. So now this now takes us to our next class, which is what? Lambda function. We're gonna be dealing with what? Lambda functions. Lambda functions. What is lambda functions? Before I come to define what lambda function is, let me first of all explain why lambda functions. For functions that are small enough, like a single line expression, and that are going to be used only once, you generally don't define function object. Instead, you use what? Lambda functions. You understand? And what is then a lambda function? A lambda function is an anonymous and one use only. Let me define it. A lambda function is an anonymous and one use only. Imagine the compound. Well, let me use a word wrap. This is what I'm trying to talk about, and this is why word wrap is so important. So word wrap, it should take it to the next line, so it won't enter where it shouldn't be. You understand? It's a one use only function. It's a one use only function that can have any numbers of parameters that can have any numbers of parameters. It can have any numbers of parameters and does some computation. Let me just put it like that. And does some computations, and that is that. So the body of the lambda function is so small, a single expression. You understand? So the result of the expression is the value when the lambda is applied to an argument. So there's no need for a return statement in lambda function. You understand? The scope of lambda function is limited, so it exists only in the scope of single statement execution. So let's see how it's working in practical. Let's consider let me get this off. Let's consider let's consider a small function that multiplies a passed argument by 2 and returns the value. Let's say I have something like def let's say I have a function that takes in an argument of x, parameter of x, and I'll say something like return it's quickly line here. Okay, let me do the proper indentation here. So and I'll say something like return x square. You understand? So return x square. So I have something like let me call the function. Let me call the function and there's f3. So if you do something like this, what will happen? It will multiply this argument, this value passed, this passed value will now become an argument. Then by it becoming an argument and substituting for this parameter, it will now be what? It will now be substituted here, which makes it what? 3 times 2. So if we try to run these, it will give us 6. So let's see. So that will give us what? 6. Okay, sorry, I have to print it. I didn't run a print statement on it. So let me say I want to print let me say f3. So let me run a print statement on it. So it gives us what? 6. You can see that the function f takes a parameter x, it returns by multiplying it by 2. So on calling the function with argument 3, it will return 6 as output. So of course we can rewrite this function as a lambda function. So let's see how lambda functions work. Let's say we have let me comment it so that it won't be as if it's the same function that is running. So let me run a lambda function, and let's say we have I can simply say lambda x such that x 2, sorry, so we have this. I can say lambda s such that x multiplied by 2. Then of course I pass the argument as this. You understand? I can say this. So if I say this, if I run it, let me say this lambda is let me call it anything. Let me store it in a variable. Let me say I want to store it in say, let me just create a variable and call it var. I don't know what to call now. So let me just say var, maybe a variable. So I now print this var. Sorry, excuse me. I print this variable. So if I print the variable now, it will give us the value. So 6, which is the same thing as you can see that there are no parentheses around the argument list, and it returns the return keyword is missing. I didn't put any return keyword, so the return keyword is implied in the lambda function, as the entire function consists of a single expression. So a lambda function cannot contain commands and cannot contain more than one expression. So that is that. So let's now apply functions to sequences. Let's apply functions to sequences. Applying functions to sequences. So applying functions to sequences. Of course, now that you have that you know about defining and calling functions, I don't need to teach you that again. Let's try to apply them to sequences. If you remember in the previous lessons, you learned about okay, I've not actually taught you about 3 types of sequences. Okay, yeah, of course, I taught you sequences. The 3 types of sequences we have is strings, list, and tuples. You understand? So we're gonna be using 3 methods in this lesson. Say we've done lambda function, so we're gonna be learning about we're gonna be using filter. We're gonna be using filter method. We're gonna be using map method, and we're gonna be using reduce method. So these 3 methods here, we're gonna be using them and applying them to our sequences. So of course, let me first of all start with filter. This filter here, of course, this filter here. So this filter, the syntax is like this. Let's say syntax. The syntax is like this. Say filter. It takes in the function. It takes in a function as the first parameter. then it takes in the sequences which you want to filter. So the filter method, what it does is it returns a sequence consistent of those elements for which the included functions returns true. You understand? That means those that satisfy the criteria given in the specified functions. So if the included function is none, the method returns those elements of the sequences that are supposed to be returned when the function returns true. So let's examine how this is working in practical. Let's say we have something like this. Let me clean this off. Let's say we have let me define an even function. Define an even value, say even value. Let me use even value. Let me define an even value. Okay, let me give it a parameter of x. Let me give it a parameter of x. Then in the even, let me say I return x, say modulus say 2 equals say 0. What am I trying to say here? I'm telling the functions to return any number, maybe any number within a range. I want the function to return to filter any number within a range that is even. You know, by saying x modulus 2 means any number that is divisible by 2. If I say x modulus 2 equals 1, I mean every number that when divided by 2 must remain what? There must be a remainder of 1. So by saying x modulus 2 equals 0, I mean any number that is divisible by 2. That is, if x, any number that's that is substituted for x that is divisible by 2 without what? Remainder. So that is that. Let's say I want to run a filter method against it. I can just create a variable, say okay, I need an even number, of course, because by saying that x modulus 2 equals 0, I'm trying to filter for even number. So I can now use the filter method, create a filter method. I can say even value, which is the name of the function. I'll call the function here. I'll pass the function as an argument, and of course let me say range of number between, it can be between anything, so I'm using between 1 to 11. So remember, range starts from whatever number you are starting from, and of course excluded the last number. The 11 is excluded, so it will be looking at from 1 to 10. You understand? So that is that. So let me print even. Let me print evens. Or no, I won't just print evens. It won't run like that. I would have to print list of evens. So I want the list of number. So I want it to give me the list of the numbers, evens. So by doing this, it will give me the list of numbers. So let me run it. Yes. So these are number divisible by 2 without a remainder. That is 2, 4, 6, 8, and what? 10 respectively. So in this example, you see that filter method uses the even value function and a range method. So the range method will generate a numerical value from this range method here. We generate a numerical value. This one. Sorry, excuse me. This one. Oh, oops. This one we to generate a numerical value from 1 to 10, which are then passed to the even function as an argument. So the even function divides the parameter value by 2, compares the remainder with 0, and return it to true or false. So the function we return true if the result of the mode operation is 0. That is modulus. That is modulus 2 is 0, indicating that the parameter value is what? Even. So the function will return false if the result of the mode operation is 1, indicating that the parameter value is what? Odd. So since the filter method will return only those value for which included functions returns true, the program will then display displays the even values. So now we go to the next one, which is the the map method. So how do we use the map method? Let me take this out. I can just comment them. They are not needed now. So I can say let's say the syntax for map method is this. You can say map and map, say map, let me say map, okay, I think function, map function, comma, say sequence, which is similar to the one we did before. So so the map method calls the included function for each of the elements in the sequence and return a list of the return value. So let me give an example. Let me give an example of how it works in practical. Let's say, let me define a function. Let me call it a square. Let me call it a square of, let me give it a parameter of x. You understand? Sorry, let me give it a parameter of x. Let me give it a parameter of x. Okay, of course. Let me return, that's a clue there, that's a sweet clue there. Let me return x times x. You understand? And by returning x times x, let me create a variable, say square equals map, of course, map square, and call the function, and of course let me create a range from range, say from 1 to 10, or let me say from 1 to 11. Let me use that as well. So let me print the list of the square. Let me print the list of square. Let me print the list of square. Square, yeah. Let me print the list of square, and let's see what this gives us. Yeah, of course, it gave us. Now, what it does is, in this example here, you see the value that it gave us. It's a multiple of itself. You understand? Take a look at this. So every 1 to 10, you know, by range will not give us the last digit. So every 1 to 10 now gives us what? Give us the multiple of itself. So what I'm saying here is this: square x, return x. That is, I'm trying to look for the square of x. You understand? Say 1 square, 2 square, 3 square, and all that. So you know, square means when you multiply a particular numerical value by itself, that is square. If I put 2 here, it gives me the same answer, no doubt. Let's check it. It gives me the same answer. No, excuse me. Sorry, not if I put yeah, like this. Sorry. So it gives me the same answer. Let's see. Yeah. So 1, 4, 9, 16, blah 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 blah, up till what, 100. So what he is doing here is that in this example, you see that the map method includes a square function and a range method. So the range method will generate a kind of numerical value from 1 to 10, which we all are aware of, which are then passed to the square functions as argument. So the square function simply returns the square of the supplied parameter. So the program will display the square value of the first 10 sequences, you know, or the first 10 sequence number. So let's say we have 1. So when we have 1 like that, it returns, when we have 1 like that, it returns so when we have 1 like that, it returns square equals map. Oh, sorry, it returns sorry, I'm lost. Excuse me. It returns the value of the first 10 sequences, that is the square root of each of those numbers from 1 to 10. That's what I'm trying to say. There was a pop-up there that I'm trying to close down. So that is that about map function. The another one that we have is the radius. You understand? The radius. We can also let me give another example of how to use a map function, a map method that converts the elements of the supply sequence into integer value. We can have something like this. Let me comment this out. And we can have something like say k. Let me create another variable here. Say k. We can have something like say k, and we can have something like say int. We can have something like say, yes, we can have int list of k. List of k. Let's say here we have let me say I have list of say 5 comma 10 point say 10.15 comma 20 comma 25 comma 20 comma 25 comma 20 comma let me say comma 25.628 comma 7. You understand? Let's say we have this. You understand? And I want it to give me only the integer, not the float. You know, if I put sorry, excuse me, let me put a comma here. So if I put a float here, it will give me the float. If I put an integer, it will give me an integer. Let's see. So okay, great, it gave me the integer. So I want you to what it did is it gave me the value but remove the float value. You understand? It removed the float value and give me only the integer value. So that is that. So you can just I want you to do the float version of it. So in this program you see that the map method includes an integer function and a list of an integer method and a list of values. So the list includes value of different types, including integer, floating point, and of course long integer. So the int function truncates it truncated the element of the list to what? Integer. So you can also pass more than one sequences in map method. The function included in map is then set to accept multiple arguments, of course. So the corresponding element from each sequences are provided as argument to the function. So if the sequence falls short, none is used for the missing value. So that is that. So now we are going to be using the radius. This now brings us the third one, which is what? Reduce. So the reduce method returns a single value that is produced by calling the function on the first two elements of the sequence. So the function then is called on the result of the function then is called on the result of the function and the next element in the sequence, and so on. For example, let's say we have something like this. Let's say we have something like this. Let me go ahead and remove this. No need it anymore. Let's say we have of course it also uses I forgot to tell you that it also does this reduce. Then we create a function. It takes in a function as parameter, the first parameter, and takes in say as the first argument rather, and it takes in say sequence, of course, just as the others, but the mode of operation is different. So let's say we have for us to be able to use reduce method, we need to first of all import func2. You understand? So how do we import func2? Let's say we import okay, excuse me, import functools. So when you import functools, you have say def, let me say def, let me say add x and y, let me say add x comma y, let me say add x comma y, let me return x plus y. You understand? Let me return x plus y. So let's say r equals func2. We're gonna call the module. We want to bind the module to so the reduce method. So we are going to be binding it to the reduce method. We can now say what do we want the function to be. Let's give the function, let's include the function, let's pass the function as an argument. So let's say range from, that is the sequence. You understand? That is the sequence. So let's print r. Let's print r. So let's run a print statement on r. Let's see what it gives us, and of course 5. What does this do? What it does is, excuse me, what it does is it returns the reduce method is kind of, okay, let me say the reduce method, which is the part of the functools module, include an add function and a range method. So the range method will return value from 1 to 10. The first two values generated by the range method are passed to the argument functions, which is add, and then result will be 3, and the next value in the sequence 3, and in the sequence I would again pass to add function, and again. So repeatedly, now add everything together. So what it takes is it will add 1 and 2, 1 year, 2 year, then it will add them 3. It will, it will keep adding like that. So that is how it will now give us a value of 55. So the func2 module is always what imported at the top, because the reduce method is defined in that module. So well, we will learn more as we progress in our next lessons. So that is that about filter, applying functions to sequences. So another thing that I don't want to forget is I think recursion, but I would rather you touch recursion. Let me just simply explain what recursion is. Recursion is said to occur when a function calls itself. Let me type it out. Sorry. Recursion. Recursion is a function that calls itself. It is a function that calls itself. You understand? It's a function that calls itself. Recursion is said to occur when a function calls itself. As expected, a function calling itself will generate recursive function calls and result in an infinite loop. You understand? So when implementing recursion, an exit condition must be included in the function, so as not for you to have an infinite loop. So recursion is implemented with the help of a structure known as stack. You get? So I'll just give an introductory, just two examples on recursion to explain what recursion, or how it is working in practical. But of course, in the data structures and algorithm aspect of our lessons, you can always, of course, look at the in-depth tutorial on recursion on that lessons or lecture series. So let's say we want to add sequences together. Let's create a function. Let's say add sequence. Then we want to create a function. I want to create a function add sequence. So let's say add sequence. Then let's see, if x equals say 1, let me say return say 1. Of course, I've given it a boundary condition, and I'll say else, I can say else return say, of course I want them to add the sequence. Let's say x plus you now call the function add sequence, then reduce the function by 1. So that is how recursion works. You understand? See that I gave my condition to check a terminating to constrain into a terminating preconditions. So then now say else run x, because you say I want to add sequence, so this x plus this, you call this function because it has to call itself here, so you call this function and what, always subtract by 1, and that is that about recursion. So if I run this thing, it will be adding if I run if I call this function, it will now, what it will do is it will be adding 1 to say, if I pass a value of say 10 to it, it will be adding the value up to what, 10. So that will now give us, let's say 55. Let's see if I'm correct. Let me call the function. Let me say add sequence. I'm calling the function. Let me pass 10 to it. Let me just print it. If I print it, this should give me 55. Yes, just as it gave us on readers. So the add function is called, passing value of 10 to it, which will be assigned to its x parameter. So in the body of the function, you see that the first line defines the exit condition, which is this. This defines what, the exit condition. You understand? So the function terminate or exit returning 1 if the value of x parameter is what, 1. So since the current value of the parameter is 10, so if you put 1, if you pass 1 to this place, it will return what, 1. So since the current value is now 10, so the else statement is what, executed, which is what, 10 plus add sequence to 9 blah blah blah, and it just keep terminating like that, calling itself and adding to what we have. So the else statement calls the add sequence function recursively, passing 9 to the x parameter, and again the x statement is now called, which executes the statement 9 plus add sequence 8 again and again and again and again like that. You understand? But if I also find the factorial, remember for those of you that are doing data science, the factorial, if I have to find factorial is when a number keep multiplying itself to its lowest time. Say when we have 5, so 5 factorial is now 5 times 4 times 3 times 2 times 1. You understand? 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and that. So we can use Python to find the factorial of a value using recursion. So let's say def factorial. Let me create factorial and give it let me give it a parameter of x. Let's say if x equals 1, sorry, excuse me, if x equals 1, return 1, else return x or x factorial, because I'm looking for factorial, so I'll multiply the x by the factorial, and of course call the function to call itself again. So by doing this, it will give me if I invoke this function, let's say fact, and put, let's say, now I told you that 5 factorial is 5 times 4 times 3 times 2 times 1. If you punch your calculator and type 5 times 4, that is 20 times 3 that is 60. 60 times 2, that is 120. So the answer that 120 times 1, that is 120. So the answer that it will give us now is 120 if I put 5. You understand? So I told you factorial multiply itself down to 1. So that is that. So let's say and I'll run it. So if I run it, oh sorry, I didn't run a print statement. Let me run a print statement on it, so as for me to have a value in the console. Let's see. So this should give us 120. So if I put 0, mathematically 0 factorial is 1. If I put 0, that should break our code. I'll tell you why it will break our code. Yes, we break maximum recursion depth exceeded in comparison. So what do we do here? Normally mathematically 0 factorial is 1, but we can make it 1 too by saying if instead of saying x equals 1, we can say if x in say 0 and 1, because 1 factorial is 1 and 0 factorial is 1. So if I put 0 here, it will give us 1. It will not break our code again. Yes, that is that. So that is that about recursion. So right now I quickly want to talk about, I want to talk about iterators, generators, and of course modules. So generator expression, but I will quickly start from module. You understand? So as for us to see how modules is working in practical. What are modules? What are modules? A module is a file consisting of a file, functions, and variable used for a particular task. A module can be reused in any other program that imports it. The functions and variable of the module becomes available in the current program. You understand? And can be used in it. You understand? In any other program. In any program, it can be used in it. You understand? So the file name of the module must have a .py extension. So to import a module to a program, you can use the import statement. You can use import in several forms. Let me think of a module. Okay, let's consider a calendar module that displays the calendar of a specific month and year. Let me see how to create. Okay, let's import. The first thing to import here is, because I want to let's create a calendar first using Python. So let's create a calendar using Python. Control this. Let's say we want to have we want to import calendar. Then first of all, import calendar. You understand? We will import calendar. The second way of importing calendar, the first way is just to import calendar. The second way is we use from calendar import. Let me see from calendar, I think, if I've not forgotten, from calendar import. Calendar is a module, so import say pre-core, PR. You understand? So let's say PR call. Let's not target it. Let's say from calendar import. No, let me import calendar, and of course there's no need to save from calendar import. Let me just import calendar directly. Import calendar. So let me import calendar, and I'll say let me create a year. Let me say year. Let me create an int. So let me create an input function so that you can you can have a room to impute a year. Let me create type in the year, type in the year number, of course, type in the year number, you understand, type in the year number. So I can now say you can say calendar, I can call calendar dot pre-out call module against the year that is being called. You understand? Let's now say, let me put in a variable, let me put in a cow variable, for example. You understand? Let me put in a cow variable. Let me put in a cow variable and let me print it. Let me print car. Let's see how this is working. Of course, let's test with 2023. You can put any year, but let's test with 2023. Okay, let's see. Okay, it said enter, type in the year, let's say 2023. Yes, it gives us the calendar of what, 2023. Yes, I think so. This is 2023 calendar. You can use Python to create a calendar. So 2024 calendar can also be created. Let's put 2024. You can put any year. Let's say, let me put 2099. This is 2099 calendar. You can create any calendar. You can create any calendar. You understand? So that is that about module. So of course we're gonna be making use of some modules as we proceed in our later lessons. You understand? So assignment I'll be giving you now is create 2024 calendar, create 2022 calendar, 2023 calendar, and 2024 calendar. Submit it on Telegram, and this brings us to the conclusion of our class for on function. So in next class we go to OOP. You understand? So we now be entering into OOP. But I would have loved to do some modules, but I think we'll do it in our later lessons. But let's quickly do OOP, object oriented programming, which is classes. You understand? So we're gonna be doing classes in our next class, in our next lessons lecture series. So thank you for your time. Feel free to share our video, click a like button, click the notification bell, and of course subscribe to our channel if you have not. Thank you and God bless.